So let's talk about Wireshark. If you haven't used it, Wireshark is the essential tool to analyze network traffic, and this is a simple project to get people started on it. You don't have to run Wireshark on Windows. You can run it on any operating system you want, including Windows. And so I'm going to run it directly on my Mac. I think I've already got this file downloaded. Let me try my... Yep, there it is. My downloads folder has this case1.zip, so I'll unzip it. Right-click, open with archive utility should be fine. Yep, there it goes. All right, so now I have a case1 folder, and in there are the files. Now here's the Rhino USB.dd that you used before, and disk copies like DD you have to open in Autopsy, but the log file, rhino.log, is in fact a packet capture file, even though it has an unusual file name extension, .log, because I think this is a really old file before the modern conventions. So I'm just going to open that in Wireshark right on my Mac. Here comes Wireshark. Okay, so when Wireshark opens, it shows you, let me get this fitting in the right window there. Don't care about the versions. All right, when Wireshark opens, it shows you recently opened files, and down here it shows you your network cards with little graphs so you can try to find the one. So you could sniff live traffic from your network card in Wireshark, but that is not a very wise move because Wireshark is not terribly secure. The safer way to use Wireshark is to open captures that were captured with simpler utilities like TCP dump. In this case, we're going to open that rhino.log. So we just click File, Open, and then go to the Downloads folder. And in here, there should be, well, all right, I should be able to find, there's the Case1 folder. And in the, whoa, I hit too many things. All right, let's try File, Open again. File close. All right, file close. Now file open. Okay, here's my downloads folder, and there's case1. So I open the case1 folder, and in here is rhino.log. So I open that. And here you see packets. Here's the individual packets. So this is a handshake sending a SYN packet to a server on port 80 and getting a SYN-ACK back and then an ACK. And then there's a GET request to load a web page. Green is HTTP protocol and the related TCP packets. And there are many other kinds of packets in here. And so, let me move my instructions to the side so I can refer to them while doing this. So in this one, what I did was break it up into different categories of traffic and save separate files. At the top of Wireshark, you have a display filter, so you can look for certain kinds of traffic. And the first thing we're going to look for is telnet. When you type a keyword, when you get it right, the bar will turn green, and when you press enter, it takes effect. So here you see the telnet packets. Now in the bottom right, Wireshark will tell you how many packets you're seeing. Let me get my window to be a little less high. All right. And so down here you see I have 6,557 packets, but I'm only displaying 568 of them because there are only that many are telnet. So I could export a separate file just with these telnet packets with File, Export Specified Packets. And now I can choose to save just the displayed 588. And I'm going to call that telnet. Save that. And then I'm going to also filter for FTP, File Transfer Protocol, and save that with File Export Specified Packets. Again, just the displayed packets, and call that FTP. All right. And so now that I've done that, then I just want to examine the telnet traffic. So I'm going to hit, the file is off my recorded part of the screen, but file closed is what I'm clicking from the menu. And now I open with File Open, just the telnet packets. All right. This is not absolutely necessary, but it does help when you have a lot of packets to filter them into smaller subsets. Now, I still have the FTP filter here, so even though I've loaded the telnet packets, I can't see them. I need to clear that filter, and now I see them. Now, telnet is a really old protocol that people really shouldn't be using anymore because it sends your data unencrypted. Now, if you look at the length of these packets, it's 69 bytes, 60 bytes, 70 bytes. Each of these packets is just sending a few characters of text to the server. It's quite an inefficient protocol, in addition to being insecure. But in this form, where you look at packets one at a time, it's pretty difficult to see what's going on. Usually what's better is to follow the stream. You right-click one of these packets and follow TCP stream, and then you'll see the data the way a user probably saw it when they were logging in. So now the red is stuff printed by the server, and the blue is stuff printed by the user. So they connect to Sun server, they log in, then they have a password, they get it incorrect and log in again, then they get a header, then they do an ls-l, and notice when the user types something, they send like the L in blue, and then it echoes back the L in red from the server. Then they send the S in blue, and the S comes back from the server. That's the way it was generally done. So this person executes a series of commands doing things on the server, and that's the first stream. And down here you can go to the next stream. If there's more than one stream of data, there's the next stream. Looks like they tried to log in and never got in. Then there's another stream, and I think there's 3 streams of data. So, by reading through those streams, you can find the answer to some questions, like I think what password got them in or what file did they download, that sort of thing. And then you can also look at the FTP image. So let me see it. So you analyze the FTP traffic similarly. If you open the FTP stuff we exported earlier, that's going to be here. Let me get my... Something weird is happening here. All right. Oh, that's the wrong. Okay, Wireshark file open. There we are. FTP.pcap is here. And in the FTP, you can see on the right, it's pretty easy to read. User GNOME, password required, password GNOME. You can read quite a lot about FTP just right from here, but you can also follow the stream if you like. Now, I still have my stream filter in. I should probably take that off to see it all. All right. So you can see there's a few FTP streams here. If I follow the TCP stream, it's very much like Telnet. I'm seeing the commands the user used to connect to the server. So they log in with the username and password, and then do various other commands like sending up an image. And there's another stream, and another stream. So again, 3 streams of data. This is FTP control traffic. These are requests to log in and upload and download files, but the actual files are not transmitted over this FTP protocol. They're transmitted over a protocol that Wireshark calls FTP data. So to actually reconstruct an image from the traffic, you have to go back to the original rhino.log file that contains all the data and clear the filter. And now you have to search for FTP-data, or filter for that, I should say. All right, here's the actual FTP data. And I put them in a separate file, although it's not really necessary, but I might as well do it. Export specified packets to FTP data. And then open just that file. All right, and now when you follow the stream here, if I right-click one of these and follow the TCP stream, this is an image, and you can tell, by the way, if you know your image headers, JPEG images have this JFIF near the start, and then it has something about Photoshop and so on. This is the way binary files look when you open them in an ASCII viewer, like Notepad. You see part of it you can read, file written by Adobe Photoshop, but a lot of it is just random letters because it's really binary data. And you can save this file and make it into a readable image, but what you have to do is not show it as ASCII, but show it as RAW. And then you see the raw hexadecimal values that John Gonder was talking about, and you can notice here JPEG images always start with FFD8. Those are always the first 4 bytes, and the last 4 bytes are always FFD9. Those are the actual file header and file footer marks that you can use to delineate an image. So this binary data is all one image. And if you save it in the raw format with Save As, you can put it in this folder, and I think I said call it Rhino1. Yeah, Rhino1.jpg. Save it with a name of Rhino.jpg. And now you can open it. If you just go into your File Explorer, here is the Rhino1.jpg, and if you double click it, it should open. Here it is. You'll see a readable image, and because you have all the packets. What encryption was the FTP password encoded with? No encryption. FTP and Telnet use no encryption for any of the data or the passwords. It's really disgusting. Nobody should be using either of these protocols anymore, although people do. They should be using SSH shell instead of Telnet, and SFTP instead of FTP that uses something like SSH. But in this case, none of that was done. So anyway, that just shows you a few things to do. You can extract images from this unencrypted data. So there's some very basic Wireshark stuff to do. Yeah, password authentication protocol, that's right. And there's more Wireshark, by the way. If you want to do a little bit more Wireshark, there's another challenge a bit lower on the page down here, which has quite a bit more, including some stuff I got from a Red Team Capture the Flag competition at one of the conferences. So here you go through Wireshark and steal some passwords, some things like FTP and HTTP. And then there's one where you actually follow a hacking activity in progress here, APT capture. Somebody hacked into a server, and then they made an encryption key and created encrypted traffic, but they transmitted the encryption key first over the network, so you can recover the key and you can decrypt the traffic. So if you want to practice with that, you should try this one, H420. So I'll stop this video.